Okay, lesson 5, day 4. So this is day 4's notes. So what we're going to do, yes. And what we have here are radicals with multiplication. I've got a binomial times a binomial, so what should we do? You mix it, how? Foil. So we have to FOIL this, which means first, which square root of 2 times 1?
1 square root of 2.
Or just
2
square root of 2. Square root of 2 times square root of x. We talked about that yesterday. What can I do with the numbers inside because they're the same square root? Lauren?
Why are they
So, square root of 2 times square root of x?
square root of 3? No.
First of all, is it positive times a negative, so it's going to be
Negative.
Negative what?
2x?
It's not just 2x, but square root of 2x. Make sure your little square root radical symbol goes over both of those numbers. And then we go back and do inside plus x. And then minus. It's x square root x. And it's because one's got a square root and one doesn't, right? Are there any like terms on this one? What's like terms? Or necessarily it would not say there's anything that's the same. I don't have just x's. X minus x, but that other x has a square root of x on it. That if it was saying expand and you saw this, what would that mean?
Quantity.
It's a quantity squared. But how do I represent that to make this the right answer?
You extend it. You draw both of them.
You draw both of them. What do you mean?
You do it like you
Write it twice, right. So that would equal the square root of 2 plus x times square root of 2 plus x. And then you have to FOIL.
Isn't the plus x and minus x?
Okay, complex numbers. I don't know why when it came through it didn't give me the little emoji that I had next to the I. It was supposed to be a little french fry thing. I don't know why. But I put one there. But anyways, I equals what?
I got the french fries.
I have the french fries too.
The square root of negative 1.
Wait, where does it say french fries?
Why do you have french fry emojis?
I don't know, it's right here. It's supposed to be a french fry emoji. Okay, I don't know. Because I saw I could input one, so I did. That's an I. Okay, imaginary numbers. And so if you think about it, if I square both sides of that equation, so square and square, then I squared will equal, well, if you square a square root, they cancel, so you're left with I squared equals negative 1. It's very important that you know this, because when we get down to problem 6, which I'll make a little bit larger here in a second, we can handle it. Then we should also leave our answers always in complex standard form. Complex standard form is A plus BI, where A is the real number and B is the complex number. So we got a real component and we got the complex component. All numbers can be written in complex standard form. Get this. 2i can be written in standard complex form. What would it look like? What's the real part of 2i? No. I is the complex. 0. It's 0 plus 2i. That's complex standard form of 2i. If I told 4, what's the complex standard form of 4? So it's 4 plus 0i. Okay. So 4 plus 0i. Now we're going to come across questions that have a whole bunch of i's in it, and it's going to say simplify. If you follow these rules, or this rule, or this order, things are going to get way easier for you. I don't have to memorize a whole bunch of different things, that if it's odd and it's this many times that it's either positive 1, negative 1, and so forth. Because there's a way to figure that out. But when we get our problems for here, they're going to be fairly simple. They're not going to have wild 700, 800 powers. They are going to be lower. And so think of this. What does I cubed really mean? Imaginary number, or I, 3 times. So guess what I'm going to do? I'm going to write it 3 times. 2 times 1, 2, 3, 4, 5. Minus 3i plus 2i. Here's a really cool thing. We know that anytime you say I times I, it becomes I squared. Yes? And according to what we just did, I squared is equal to negative 1. So this is what I'm going to do. I'm going to go through and I'm going to circle all my pairs again. I got a pair in that first group. I've got how many pairs in the second group? How about third group? And the last group? Okay. By going through and circling my pairs, I am going to be able to use simple substitution and replace that circled blue, in this case, with a negative 1. So, what does it look like? It looks like 3 times negative 1i plus 2 times negative 1 times negative 1, because there's 2 of those, I. Is this making sense?
No. When am I ever going to use the top? I swear to
3i plus 2 times negative 1. Yes. Now, to continue, we will simplify this. What is 3 times negative 1? Negative 3i. Plus, wait a minute, 2 negatives make a positive. So it's a positive 1 times 2 is 2i. We didn't actually touch the negative 3i at all, so it just comes along for the ride every time.
minus 2.
And then minus 2. We got like terms. We've got a whole bunch of i's here, so we're going to combine them. If I have a negative 3 of them and add 2 of them and subtract another 3, or what's negative 3 minus 3? Negative 6
Oh, wow.
plus 2. So it becomes negative 4i minus 2. That is what it equals, but just like when we have quadratics or polynomials, we like to put them in standard form. We always like to put the real number first. And so the answer here is negative 2 minus 4i. Done.
That's easy. Is this one gonna
So
go on?
simplify this one. The square root of negative 3 times the square root of 4 plus 3 times the square root of negative 2 times the square root of negative 9 plus the square root of negative 16 plus the square root of 16. Now, I know at one point we talked about that if you multiply 2 square roots together, those numbers inside you can multiply together, right? Unfortunately, when it comes to complex numbers, we hopefully realize we can't take the square root of a negative number. And so we're like, okay, in the middle here, if I was to multiply negative 2 times negative 9, I get a positive 18, which we could reduce. But the negative's gone. I don't have to worry about negative numbers or i's. Unfortunately, because we're dealing with negatives and complex numbers, you cannot just multiply the numbers together. We have to take care of the i's first before you multiply them together to get that 18. Because the square root of 18 is still part of it, but we have to have the I and the I come out. And if you had someone like Havlicek last year, he would have said poke an eye out. Because what's happening is that we don't like negatives inside our square roots, so we shove the negative out and it becomes an eye, or we poke an eye out. So that's my first move on all of these. Okay? Let me get that red line out here. So as I do this, I don't like the square of negative 3, so it becomes square root of 3 I. Well, while I'm going along here, I might as well clean this up as well. What's the square root of 4? Times 2. Plus 3 square root 2 I. Because again, poking an eye out.
Is the eye inside the square root?
The i's are not inside the square root. You can put it in front. You can put it at the very end. I'm going to leave it in the spot where it came from first. We're going to clean that up after, okay? Then it becomes times square root of 9i plus square root of 16i plus 4. So at this step, I might move the i's to the front or to the back. I like to leave them all the way in the back. Some people like to put them in front of the square root, but after the coefficient, so that way they don't get it mixed up with inside a square root, because you cannot square root a negative an I. So this becomes 2 square root 3i. Just moving things around, because numbers are, when you're in multiplication, that's associative, right? Now, can you guys agree that square root of 9 is just 3? And 3 times 3 is 9. So I'll have plus 9 square root of 2 I. Because square root of 16 is, so it's 4i plus 4.
That's it?
Got to keep going. I have I, so therefore I can change that to negative 1. Now maybe I can do that, put the negative 1 underneath, and then when I go to rewrite, it's 2 square root 3i. What then?
Negative 2 or
Minus 9 square root 2 plus 4i plus 4. We're not completely done because we're not in standard form. Question?
I didn't catch.
So I have to rearrange. I want to put the stuff that doesn't have i's first. That would be a negative 9 square root of 2 plus 4, right? And then at the end, I'll put a plus 2 square root of 3 I plus 4i. Unfortunately, if you were to look this up in the back of the book, this is not what you would see. The only reason you wouldn't see it is because they like to have, again, a plus bi. They want to establish what is a, what is b. I is on 2 of those numbers. So I'm actually going to factor I off.
What?
Yes. So this becomes negative 9 square root of 2 plus 4. They put parentheses around that to say, hey, that's my real number. It looks complicated, but that's my real stuff. And then they go back and say, I'm going to factor off I.
Is that a 9 or a 4?
That's a 9.
Oh, so then you just do 2 square root.
Yeah. This becomes 2 square root 3 plus 4. I just factor the I off and put it at the end. So therefore, you know that this is like A and that's B. That's the only difference. Okay? Just put it into proper standard form.
We're done?
Now, we're going to talk about areas of similar geometric figures. The areas of similar geometric figures, they have something that's really cool. It says the blank of the areas of similar 2D geometric figures equals the blank of the scale factor between them. Uh-oh. How about the ratio of the similar 2D objects? So you got your similar figures. They could be rectangles, squares, triangles, whatever. If we know they're similar, and we can find the scale factor between those figures, the area is just kind of like if you wanted to label, okay, if we labeled their sides here, and I called them, or the label is in inches, right? If we're talking about the ratio of sides, you'd say it's 3 inches to 4 inches. But if I was talking about area, it goes from inches to inches squared. Guess what happens to the ratio when you talk about from the ratio between them to the ratio of the areas? It becomes the square of the ratios. And this little activity here is going to show you this. It says that the scale factor between the two rectangles is 4. What is the ratio of the areas? So wait a minute. If the scale factor between them is 4, that means the larger one is 4 times larger than the smaller one. Yes? Okay. So if the width is W in the small one, what's the width of the larger one? I think we actually might have those separated. But if this is W, then what is this one? 4W. Because it has to have that ratio of 4, right? That means that same ratio is for the L's. If this is L, then what's this one? 4L. You guys agree with me? That's how we did ratios. That's how we found our third side on some things, or found that ratio to find X, Y's, and Z's. Can you guys tell me the area of 1? What's the area of rectangle 1? It's WL or LW, length times width, yes? What's the area of?
4WL.
It's 4W times 4L, and wait, 4 times 4 is 16 WLs. Now wait a minute. Does that make sense for what they said above? We said above that if I did a ratio of the corresponding sides, I'd have 4W over W, right? The W's cancel, and that's why I ended up with 4. What's 4 squared? 16. So the ratio of our sides is 4 to 1 or 4. What's the ratio of the area? It should be 16 to 1. Because it's 16. Why? Why is it? Because what was the area of the large? 16 WL. What was the area of the smaller one? And what happens with the WLs?
Cancel.
And you're left with 16, which is 4 squared. So, what does it mean? It means that, hey, if I give you a problem that just says the radius of one circle is R, the radius of the second circle, which has to be smaller because the radius is 3R or 3/5 R, what is the ratio of the area of the first circle to the area of the second? Okay, wait a minute. We don't have a picture of this. So, here's circle 1. Radius is R. Here's circle 2. It's slightly smaller at 3R over 5, right? We could do things the long way because if we know the radius, we can find an area, right? Or we can say that almost all circles are similar because the radius is really the only component that should be the determinant of that. That's a 5. 3R over 5. And so, first of all, set up what's the ratio of corresponding parts. And it says large, or the area of the first to the second. Well, the first one is the large one. So what's the radius of the first one? R over 2. The second one, which is 3R over 5. this would be the ratio or the scale factor, right? You guys see how I'm doing that? Corresponding parts, that ratio sets up the scale factor. And we said if I know the scale factor to find the ratio of the areas, I just need to take that ratio and square it. But here's the thing. I've got a fraction within a fraction, so I probably should clean that up. How do I clean that up? If I divide by fraction, I'm actually by the reciprocal. So it becomes 5r times 5 over 3r. What happens to the r's? So it becomes 5 to 3. So this is the ratio of the radiuses from the large to the small. It's 5 to 3. What's the area ratio? It is 25 to 9. That's it. And if you don't believe me, then all you have to do is find the area of the large one, which would be pi r squared, right? The small one would be pi times 3r over 5 squared, and divide them. You will end up with that ratio.
How do you do pi r squared? Oh.
Your homework is for day 4, lesson 5, page 47, 4, 7, 12, 13, 15, and 16. Have a great day.